matter is made of atoms. Atoms are mostly empty space. They consist of a very heavy, very dense collection of particles in the center, called a nucleus. That's the nucleus of the atom. Around the nucleus, consisting of less than 1% of the mass of the atom, are electrons. And these electrons are in orbitals, which are areas around the nucleus in which the electrons can be found. What is an electron? Well, atoms are made of 3 subatomic particles. Subatomic means smaller than an atom. These 3 subatomic particles are the proton, the electron, and the neutron. The proton and the neutron are found in the nucleus. They are called nucleons for this very reason. The electrons orbit around the nucleus at fixed distances, called orbitals or shells. The 3 subatomic particles are differentiated by their mass and their charge. Their relative mass is how heavy they are in relation to a proton. We can't use grams or kilograms to measure them. So a proton has a relative mass of 1. Say it's got a mass of 1. The neutron has exactly the same mass as a proton. So we say it also has a mass of 1. The mass of an electron is much, much smaller and lighter than that of a proton or a neutron. It does have a mass, it's a very small mass, but for our purposes we'll say its mass is 0. Because when we're doing our calculations, we just 0. So what differentiates them, other than their mass, is also their relative charge. Protons have a positive charge of +1. Electrons have the same charge as a proton, but the opposite sign, the opposite charge. So it's -1. For the neutron, the clue is in the name, neutral, charge of 0. So the proton and the neutron are found in the nucleus and are known as nucleons. How do we know how many protons, neutrons, and electrons there are in an atom? Well, for that we have to look at our periodic table. You should be very familiar with the periodic table at this point. The periodic table is a list of all of the elements that exist, all the different types of atoms that there are. So if we zoom in and we have a look at the symbol for example, carbon, you'll notice that it has 2 numbers. The smaller of the 2 numbers is called the atomic number or the proton number. It's always the smaller number. The atomic number is the same for every atom of carbon. It's always 6. That tells us the number of protons. So I know that every carbon atom has 6 protons. The larger of the 2 numbers, don't forget that they're not always in this order. Sometimes they're on the top, sometimes on the bottom, sometimes on the left or on the right. For the IGCSE syllabus, they are always in the same order, and there's a key on the periodic table. But if you're doing your own research and you find a periodic table, don't think of it as the number on top, the number on bottom. It's the small number and the large number. The larger of the 2 numbers is called the mass number. It's also called the relative atomic mass number or the nucleon number, which gives you clues to what it means. It is the number of protons and neutrons added together, because they are the nucleons. So now I know that carbon has 12 nucleons, that's protons and neutrons. I know that it's got 6 protons. I know that a proton and a neutron both have a mass of 1, so that tells me it's got 12 minus 6, 6 neutrons. So we know the number of protons and neutrons. So what about electrons? Well, an atom is a particle with no overall charge. It's made of particles which have charges, which means that the number of positives must equal the number of negatives. that tells me the number of protons is equal to the number of electrons. So in this case, it is 6 of each. 6 protons, 6 electrons, because the charge is 0. So for carbon, it's got 6 protons, 6 neutrons, and 6 electrons. Careful though, because sometimes they're different numbers for electrons if the particle is an ion, or a different number of neutrons if the particle is an isotope. But you'll be given that information. Okay, so that is how the atom is structured, and that is how you find out how many subatomic particles it has. Thanks for watching.